For today's video notes, you will need IC65. This is part 2 of standard 15. We are continuing to look at surface area, but this time the geometric solid we are focused on will be a pyramid. So just like last time, as a reminder, surface area is going to be the total area of all the faces or all the surfaces of a geometric solid. So for pyramids, we're going to take all of the triangular faces that meet at a point and then the base of the pyramid, and we'll add them all up. To do that quickly, we can use P times L over 2 plus capital B. Now, some of you are familiar with the cursive L from earlier in the school year when we were working on our special right triangles, those 30, 60, 90s, 45, 45, 90s. This L is going to be a little bit different than that, so we're going to use L in a different way for this standard. Okay, P is still what it has been for the last few standards. We're looking at perimeter. It continued to be of the base of the geometric solid like it was for prisms yesterday. L, that new cursive L, is called the slant height. And what it does is it describes the difference between the point of the pyramid, which is called the apex, and then the base edge of the pyramid. And we'll look at what that looks like in some figures down below. Capital B is the same as yesterday. That's going to be the area of the base of the pyramid. So we'll find that using our formulas from standard 14 for area of two-dimensional figures. And then capital H, like yesterday, is going to be the height of the solid itself, which will describe the distance between that apex, that point of the pyramid, and then the center of the base. That's where the height is located in pyramids. And then there's one other detail about pyramids that we need to know, not because it's part of the formula, but because sometimes we're given the information, and that's a lateral edge. The lateral edge is going to be the distance from the apex again, that point of the pyramid, but this time it goes to the vertex of the base. So we have 3 different things that start at the apex of a pyramid and travel to 3 different places. The slant height is from the apex to the base edge. The regular height is from the apex to the center of the base. And then the lateral edge is from the apex to the vertex or a corner of the base. Okay, let's take a look at identifying these key features in some pyramids. So for each of the pyramids below, we're going to shade the face that should be used as the base. I'm going to continue to use yellow for my shading. And then we will highlight and label a distance that represents the slant height. Okay, slant height, that's going to be that cursive L. I might also label the capital H height and maybe the lateral edge on a few of these just so that you can see how they're different. But what really matters for us when we're doing surface area is identifying the base correctly and identifying the slanted height correctly. Okay, so for this first pyramid, the apex is this point at the top, and the base is the face that is across from that. If there's a shape in your pyramid that is not a triangle, that must be the base. So for this pyramid, the base is rectangular, it looks like. It's a little bit slanty, but remember that's just to get it to look 3-dimensional to our brains. So this is going to be a rectangular, it might be a square, but we don't know that necessarily for sure, pyramid. And the slant height is actually already shown in this rectangular pyramid on one of the faces. It starts at the apex and it travels to the base edge. This down here is the base edge. But a little bit more specifically than that, it makes a right angle and it also divides that base edge in half. So that right there is our slant height. Moving on to the second shape, we can see our base again, this not triangular face. This time it has 1, 2, 3, 4, 5 sides. So this is going to be a pentagonal or pentagonal pyramid. Different people say that word different ways. Our slant height does not look like it's already drawn in. You might be tempted to draw it in straight to the front, but that's going to get a little bit confusing later on down the road. So I'm going to try to be consistent, and I'm always going to try to sketch it in kind of over to this right-hand side. That's going to be the slant height. Remember, it makes a right angle, and then we could mark these as being congruent to each other because it travels to the midpoint of that side. Okay. Number 3, we've got a face at the bottom here that's not a triangle, so that's going to be our base. We shade that in. And then we do have a slant height drawn in again, and it's over here along the edge, that right-hand side of the shape. That's our slanted height, making that right angle, dividing that side up in half. And then for this picture, I'm going to actually go ahead and name this right here. That is the actual capital H height. It starts at the apex and then comes down through the middle of that pyramid to the center of that base. So that's what the capital H height of the pyramid would look like. This base 1, 2, 3, 4, 5 has 6 sides, so this will be a hexagonal or hexagonal pyramid. All right. Last but not least, this pyramid has all triangular faces, but since the apex is here at the top, we're going to choose the triangle at the bottom to be our base. Go ahead and shade that in. We've got a slant height right here. I'm splitting that side in half, and because that's a triangular bottom, we're going to call this a triangular pyramid. Okay, I showed you what the capital H height looks like in one of these pictures, so I'm going to go ahead and show you what a lateral edge looks like in one of them as well. I'll do that on this last one. These solid connectors at the edges of the triangular faces that meet at the apex are the lateral edges. So they're the place where two of those triangular faces come together. So anytime you see one of those solid lines coming from the apex down to one of the corners of the base, that's going to be a lateral edge. Again, you don't need that to find the surface area, but sometimes they give you the lateral edge, and so you'll have to figure out a way to use it to help you find, usually the slant height, but sometimes also some features of the base of the shape. Okay. Now, in these pyramids, there are all sorts of triangles that hide that we might need to use to help us track down features that are missing that we need for solving problems. We can kind of see the triangles start to be created in this number 3 pyramid. If I were to go ahead and connect that capital H height to that slant height there, we all of a sudden have a little right triangle that's hovering inside this pyramid. We can also kind of see in this last triangle, there are right triangles on the face of these shapes as well, okay? And so both of those different right triangles can help us to track down features that we might need to solve problems. That's what this little investigate box at the bottom is for. So, since our formula involves L, the slant height, sometimes we need to find that L using a right triangle that exists in the pyramid. And along with that right triangle, typically it's going to be Pythagorean theorem that helps us out. As a reminder, that's our c squared equals a squared plus b squared equation. Okay? And the reason why it's usually Pythagorean theorem is because we don't often have angle measures. And so that means our special right triangles and our sine, cosine, tangent doesn't usually work out super well. And so if we look at this number 3 right triangle that we created, we might have a situation where that capital H height through the middle of the pyramid is connected to that slant height out on the face of the pyramid. And then this feature along the bottom can kind of be represented by different things. If our base is one of these regular polygons, that's actually the apothem, okay? If our base is a square, we can technically call it the apothem, but we can also call it a half of a base edge. So that bottom piece sometimes is a little bit tricky to track down, but we'll practice finding that. And so if we look at that triangle, that slant height, that L, would be our C value across from the right angle. And then our capital H height and our apothem would be the A and the B part of that formula. The other option is the right triangle I showed you here in number 4. So if we look at this right triangle, the slant height is actually over here on the left side of that triangle connected to the right angle. Across from the right angle is one of those lateral edges. Okay, we don't really have an abbreviation for lateral edge, so we just have to fill that in. And then the bottom of that triangle is half of this base edge. So half of that distance along that base edge. And so Pythagorean theorem in that case, the C would be that lateral edge. Squeeze that in there. And then the slant height and that half base edge would act as the A and the B part of that formula. So you have to be really careful at visualizing whether you're using this triangle that's kind of hovering inside the pyramid or this triangle that's laying on the face of the pyramid when you're trying to solve for things that are missing.